Hi, in this question, we're told that a small ball is projected with a speed of u meters per second from a point at the top of a vertical cliff. The point is 25 meters vertically above the point N, which is on horizontal ground, and the ball is projected at an angle of 45 degrees above the horizontal. The ball hits the ground at a point A, where AN is 100 meters, as shown in the diagram, and the motion of a ball is modelled as that of a particle moving freely under gravity. Using this model, we need to show that u equals 28 meters per second. So because u has a horizontal and a vertical component, we need to resolve both horizontally and vertically. If we resolve vertically upwards, then using suvat, the vertical displacement coming from the origin to the ground will be the negative 25. We can find the initial velocity. This will be going vertically upwards, which will be u times the sine of 45. And the sine of 45 is 1 over root 2. So the initial vertical velocity will be u over root 2. And the horizontal velocity will be the cos of 45, which is the same as the sine of 45. So this will be u over root 2. The final velocity we don't know. The acceleration, if we're resolving vertically upwards, goes against gravity, so this will be negative g, and the time will be capital T. Resolving horizontally to the right, the displacement now will be from N to A, which is 100 meters. The initial velocity is u over root 2. V we don't know. The acceleration is 0 horizontally, and the time is capital T. The two times are equal because the time it takes to go from the platform to the ground will be the same time it takes to go from N to A. So they both equal to T. And because we don't know the final velocity, we'll use the equation that S is ut plus 1/2 of at squared. So resolving vertically, we'll substitute in our values. Negative 25 will be u times t plus 1/2 of a times t squared. Resolving horizontally, we'll have 100 will be u over root 2 times the time, and because the horizontal acceleration is 0, this term will become 0, so we'll just leave that as ut over root 2. So now we've got two equations with two unknowns. What we can do is make t the subject of the horizontal equation, and then substitute that expression for t into our vertical equation. So therefore, t will equal 100 root 2 over u. Then we'll substitute this into here and here. So negative 25 will be u over root 2 multiplied by t minus 1/2 of g times the t squared. Now the root 2's here will cancel, so will the u's, and we can expand out in this bracket. So we get negative 25 will be 100 minus 1/2. Well, 10 root 2 squared will give us 20,000. 20,000 times 1/2 will give us 10,000. And we'll times that by g, so minus 10,000 g over the u squared. Now we can move all of this over to the left-hand side. And we'll move a negative 25 over to the right-hand side. So u squared will be 10,000 g over 125. We can work this out. We get 10,000 times g over 125. So u squared is 784. We'll take the square root, and we get u equals 28 meters per second. Okay? And then for part B, find the greatest height of a ball above the horizontal ground NA. So if I sketch the trajectory of this ball, it would look something like this. We want the greatest height here, h. I'll call this h. And because this is a vertical height, again, we'll resolve vertically. So resolving vertically, displacement is now, I'll label this height here as x. The initial velocity is u over root 2, and we know that u is 28. And the vertical velocity, well, at this point of a maximum height, v will equal 0. The acceleration is again against gravity, and the time is now not relevant. So we'll use v squared will equal u squared plus 2as. We know v is 0, u is 28 over root 2, plus 2, lots of a, times the vertical displacement x. We'll move this term over to the left-hand side, and we'll work this bit out on our calculators. So 28 over root 2 all squared will give us 392. So x will be 392 over 2 times g, 19.6. So x equals 20. If we go back to our diagram, if x equals 20, and the distance from the origin to the ground is 28, then the maximum height h will be 48 meters. And for part C, in a refinement to the model of a motion of a ball from O to A, the effect of air resistance is included. This refined model is used to find the new value of u. How would this new value of u compare with 28, given in part A? Well, if we're including air resistance, that will act against the motion of a ball. So the initial velocity would be greater than the 28 meters per second. And for part D, state one further refinement to the model that would make the model more realistic. We could use a more accurate value for the acceleration due to gravity. Okay? Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can download lessons on projectile motion from my website, mrmathematics.com.